Hi students, today I am going to explain two problems. The first problem is based on X bar and R chart. So let's first read the problem and try to understand it, and then we will discuss the solution. So let's see, on a production line, Jane and Jack each measure a standardized part dimension. So there are two quality operators, Jane and Jack. They measure the standardized part dimension every hour. They use the same measuring device as mentioned here, and the table here given to us. That table shows that their measurement data for 30-hour period. They measure each hour, so we should have 30 parts, right? 30-hour period, and for each part there are two samples. So Jane has two samples, Jack has two samples, and we have a total of, as you can see, 30 parts. So that's that. We have the data, and we have been asked to develop X bar and R chart using the data. And not only that, that's first step. In the second step, we need to determine the estimates of the repeatability error. What is a repeatability error? Repeatability error meaning the error within the operator. And then the reproducibility errors. That means errors because of different operators. So error between different operators, right? So this we need to calculate the estimates of these two errors, repeatability and reproducibility. So here I have some formulae listed, but let's not worry about them right now. Right now let's see what we can do with the table data. So I have basically the same data I have put in a spreadsheet here, exactly same data. Now I'm going to copy this data for Jane and Jack, all these values, right? I'm going to copy all of them here. I copied them, and then I'm going to post them or paste them in Minitab. Okay, so we got all the data correctly entered in Minitab. We have four different columns, first two columns for Jane and the second two columns for Jack. Okay, next we need to plot X bar and R chart for combined data for Jane and Jake both. So that's first thing we will do, that is we will do X bar and R chart for the combined data. Then after that we will plot X bar and R chart only for Jane. Then third we will plot X bar and R chart only for Jack. Okay, so let's do step by step. So first stat, then control charts, variable charts for subgroups, and X bar R chart. Okay, here all observations, are they in one column? No, so I need to select the second option. Then I'm going to click in this box, and since first I want to plot X bar and R chart for the combined data for both Jane and Jack, I need to select all the four columns. So C1, select, C2, select, C3, select, C4, select, right? And then suppose I want to conduct some tests also, so I am going to click on X bar R options. Here I'm going to select the tests, and I can perform any number of tests, right? So let me see, except for test number 5, I'm gonna maybe select all the remaining tests. Okay, so 1, 2, 3, 4, and 3 at the bottom. These 3 tests I'm going, only 5th test I'm not going to perform, or you can perform all of them, doesn't really matter. So click OK, and then I'm going to click OK to see the chart. So that's my chart for the combined, right, combined data. So what we can do is we can copy this graph and we can paste it in our solution document. I can say X bar R chart for the combined data, right? I can paste it here. So that's the chart that we have. Now based on the chart, we can calculate the measurement error. Measurement error, the formula is given here. Measurement error, which is also designated by sigma measurement. The formula is, I don't know whether you can see it or not. Let me try to enlarge it. Okay, so sigma measurement is R bar over D2. Now what is R bar? Let me zoom it more so that we can focus on the formula. R bar by D2, right? So R bar value is, we can get it from that value, we can get it from the plot here, which is 0.00607. So let me type 0.00607. That's the R bar value divided by D2. Now what is D2? D2 value you can find in the table at the back of your book. Here I have a page 555 of your book, and on this page you will see control chart constants table. We are interested in the D2 value, and since we here we have 4 samples, right? We are working on a combined data, so because of that I can select sample size 4 and look for the D2 value here. D2 value you will find 2.059. Okay, so let's type that here, 2.059. If you do the calculations, you will get the answer 0.00295. Okay, so that's basically what we get is a measurement error. Next we will go back to Minitab file here. I will minimize this. Now we will plot the Xbar chart only for Jane. So I'm going to again click on stat, control charts, variable charts for subgroups, okay, Xbar and R chart, and only difference this time will be I will deselect C4 and C3. Only first 2 columns are important because we are doing it only for Jane. Everything else looks fine. Then I click OK, and that's the result I get. There are obviously some tests have failed in this region, so process is not within control, but let's not worry about that. Let's copy this graph, copy graph, and let's paste it here. We can call it Xbar and R chart for Jane, right? I can select that, make it a bold maybe. So that's our plot. Then next we want Xbar R chart for Jack. So I'm going to select that and make it a bold, and we go back to Minitab. I want to minimize this chart as well, and then I need to now focus on column C3 and column C4. So I'm going to click on stat, again control charts, variable charts for subgroups, and Xbar R chart. This time I want to clean this box here and then select C3 and C4. The rest everything is same. I will plot Xbar and R options, they are same, so let's not get into that, and then click OK. So here this process, if you look at the Xbar and R chart, some tests have failed, and this looks even better than the Jane's chart, because some points are clearly going out of the upper control limit in Xbar, also in R bar chart, at least in Jane's case, the points did not go beyond control limit. Here they are violating the upper control limit, right? So that's okay. We can copy this graph and paste it here. Now first we have to calculate what we have been asked is repeatability error within operator error, right? And I have the formula here. Let me again zoom into this thing. So you can see in this formula here, repeatability error, which is called as sigma repeatability, is equal to R bar by D2. Now we can use, because this is within operator, we can either use Jane's chart or we can use Jack's chart. So looking at both the charts for Jane and for Jack, as we noticed before, Jane's charts, even though some of the tests have failed in this region, but the Jane's chart looks better than Jack's chart. None of the points you see are beyond the upper control limit or lower. They are here on lower control limit, but they are still, the tests are not failed there, right? So that looks, so we will use Jane's data or Jane's charts to calculate the, to represent the repeatability error, okay? So in this formula we need to type the values now, equal to R bar value we can get from the Jane's chart. You will see that R bar is 0.0025. So we type that 0.0025 divided by, now D2. Again we need to go back to this table here, D2. This time the sample size is not 4, and that 4 sample size was for combined data. Now the sample size is 2. So we look for the D2 value for sample size 2, we get 1.128. I'm going to type that here, 1.128 equal to, if you do the calculations, you will get the value 0.00222. Okay, so that's our first answer that we got here. Second answer would be reproducibility error. I have a formula written here for reproducibility. That means this is between operators error. So the formula is sigma reproducibility is equal to actually the square root of measurement error square minus repeatability error square. So we need to type the measurement error. We already calculated that. That's, I'm going to copy this here, okay, measurement error, and we can put here that value, right? Then the repeatability error is 0.00222. So let's do that, 0.00222, and if you do the calculation, you get the answer 0.00295. Okay, so that's basically our second answer. First answer is repeatability error and the second answer is reproducibility error. So to summarize this problem one more time, what we did is we took the table values and we entered them correctly in Minitab. Then next we did Xbar chart for the combined data with a 4 sample size. So we did that, and based on that combined data plots we calculated measurement error using the R bar value and D2 value that I already explained. Then next we plotted the charts for individual operator. For Jane, this chart, and for Jack, another chart, right? So based on these two charts, we noticed that the first chart, which is for Jane, this pair of charts is better than compared to Jack's charts. So we used Jane's chart to calculate the repeatability error, right? So we used her R bar value 0.0025 and divided by the D2 value which we got from the table. That gave us the repeatability error. Then using the formula for reproducibility error, which is nothing but the square root of measurement error square minus repeatability error square, we got the final answer, which is reproducibility error, that is 0.00295. So that's a simple problem. Now let's discuss the second problem. So I'm going to read the problem first and then we can discuss the solution. A production line conducts final inspection on samples of 25 engine cylinder blocks. So there is a production line for engine cylinder blocks and inspection, basically final inspection on samples of 25 engines, right? These engines are selected at random. The table below gives us summary of the most recent 30 samples. Each sample has 25 cylinder engines, right? And based on the table, we need to plot appropriate control chart, and then we need to comment on whether this process is in statistical control. Now let's first study the table. The table gives us 30 samples, sample number 1 to 15 here and sample number 16 to 30 in this third column here. Each sample, as I said, has 25 engines and number of defects per 25 engines are given. Number of defects. They are not variable values as we have seen in the first problem. These are basically the number of defects, right? So 13, for example, in first sample there were 13 defects in the 25 engines that were expected. The second sample there were 65 defects in 25 engines that were selected, and so on and so forth. Now then this is different from this table here in the problem 1. Here what we have given actual measurement values. In this table here, in this problem, these are not actual measurement values, rather they are the number of defects. So we can so this is not an Xbar chart problem. We need to do a different chart. Okay, so first thing what I did is entered the data in Excel spreadsheet so that we can copy that, and then I am going to copy this data. Let's first close this problem that we were discussing before. I'm just going to close the mini tab and open mini tab 17 again. Okay, so we are good to go now. I am going to copy, as I said, first 15 sample results and copy them here. Then in the same column from row 16 onwards, we need to copy the rest of the sample results, number of defects here from the last column. So I copy all of them and I'm going to put them here. So that's the correct way to enter the data in Minitab. So we got the sample number and we got the sample and the number of defects per sample, right? So which chart should we plot? I'm going to click on stat, then I'm going to click on control charts and control charts for subgroups. No, we don't want that. We want attribute charts. Okay, we want attribute charts because we don't have a variable values, rather we have number of defects, as I said before. So attribute charts, and for this type of data where we get the number of defects per sample, we can, as you can see here, if you read that highlight, that pop-up there, it talks about the type of data that we can use this chart on, basically a C chart. So let's click on C chart. Right, variables, C1 is our variable, so we did that, we selected that. we can draw some labels, we can type some title, subtitle, whatever we want to do, but I'm not gonna do any of that. Then C chart options, we need to also be able to say that whether the process is in control or not. So we can conduct some tests. I'm going to conduct maybe all of the tests, okay, all the tests, and I click OK, and we are ready to plot the chart. So I'm gonna click OK here. Looks like we have a problem, right? That there are lots of red dots here. That means the process is not under control. There are some problems, right? So what I'm going to do is I'm going to copy this plot, copy graph, and I'm going to paste it in my Word document. Here, and I can say the process is not within control, and we can do what we can do is we can copy these test results. The test that is failed on these red points is test 1 point more than 3 standard deviation from the center line, right? The test, it failed at these points here. So I'm going to copy that report, Control C, and I will paste it here to show why the process is not in control, where the tests have failed. These red points are also indicating the same. So that's basically it. This is the solution for second problem. Okay, with this I will stop now.